and it is unique word abbreviation. I think this is a reading problem. We have to be careful because there's a lot of edge cases, otherwise we're gonna make mistake. So the abbreviation of a word is a concatenation of the first letter, the number of characters between the first and the last letter, and its last letter. So if the word has only 2 characters, then it is an abbreviation of itself. But it didn't mention what about if there's only 1 character. It is also. So for example, if there's only 1 character A, so the abbreviation is itself, but it didn't mention about that. So it means that there's a lot of problems with this problem, because definitely this is the premium problem. Nobody checked. There's not so many people checking this kind of a problem. Definitely there's a lot of confusion. It didn't say about that, but we should know about that. If there's only 1 character, so the abbreviation gonna be itself. So if there are 2 characters, so for example AA, so the abbreviation gonna be AA itself. But what if there are 3 characters AAA, so it's gonna be something like A1A. But if there are 4 characters like AA, so it's gonna be A with 2 and A. So this is gonna be the meaning. So if we understand here, let's just continue. So this is just the valid word abbreviation class, and inside of the class we're gonna have a dictionary. This is a list of string, and we only have 2 conditions. We're gonna return true, otherwise we're gonna return false. So the first condition is there's no word inside the dictionary whose abbreviation is equal to the word's abbreviation. Let's just use an example. Let's just find out true. So for the second case, it's gonna be true. So the second case is cut. So what's gonna be the cut? It's gonna be C2 with T. So for here, can we find C2T? So this is a D2R, D2R, C2E, and C2D, but there's no C2T. So this means for this card, we're gonna return true, because it meets the first condition. So the first condition is there is no word inside of the dictionary whose abbreviation is equal to the word's abbreviation. Because there's no word, so we're gonna return a true. Now let's just continue to check the second case. So for any word inside of the dictionary whose abbreviation is equal to the word's abbreviation, so that word and word are the same. Let's just find another example maybe. I'm not sure if we can find so for example, this cake. So this cake, we can write it as C2E, right? And there's also inside of the dictionary, there's also a cake, C2E. So even we can find it, but they are the same. As you can see, it is a cake, it is a cake. So we're gonna return a true because there's only 1 cake. Maybe we can find another C2E. If we can find another C2E, let me find another. Maybe inside of the dictionary there is a cake, C-A-N-E. So this is also a C2E. But this K is not equal to cake. So in this case, we're gonna return a false because we find 2 words. 1 word is cake, it is okay, but there's another word that is different from the cake, so we're gonna return false. I don't know if there's any application for this problem, but definitely this problem is really boring. We just need to implement the description like that. So let's just continue to solve the problem. As we are going to check the second case, so this means even we did get a abbreviation. So for example, like C2E, we have to check if how many numbers of this C2E. If there's only 1, it is okay, it's like a cake. But if the number is 2, definitely we're gonna return a false. But before that, we also needed to put the all those words inside of the dictionary. We needed to put it inside a set, because what about if there are 2 cake? That is appeared in the testing case. That is why I talk about it. So if there are 2 cake, this is 1 cake, another cake, so definitely the number gonna be 2. So this is why we needed to turn this dictionary into a set. Now let's just continue to solve the problem. So I'm gonna use self.d. It's gonna be default and dict and the integers. and then we're going to use a self.set. So it's going to be set of dictionary. Yeah. Now I'm going to check the unique word inside of the dictionary, because if there's a duplicate, it will cause problems, as I talked before. Because basically we just need to check how many abbreviations. So for example, this is the CE. We just check, oh, there may be one abbreviation. So while we find this cake, first we're gonna check if this cake is appeared inside the set. So this is my set. So if it is inside, I also need to check what is the length of the abbreviation. So for the abbreviation, it is a C2E. So how many C2E inside of the dictionary? There's only one. That means it is unique for this cake. Yeah. Now let's just put all the words. So for word inside of the self.s, we want to put it inside of the dictionary. We need to check the length of the word. So the length, if it is less than or equal to 2, so we can put it directly. So self.d with this word gonna plus equal to 1. So otherwise, if the length is more than 2, so the self.d, so inside it's gonna be the word 0 and plus let me use a string. It is the length of the word. It is first. Oh, we're gonna use a string. It is word 0, the first letter, and then I'm gonna use a string, and inside it's gonna be just numbers. Yeah, so let me just try to find how many of them. So it's gonna be the length of the word minus 2, and then we're gonna turn it into a string, and then we're gonna plus the last character inside the word. Yeah, and for this d, it's gonna plus equal to 1. So this is the first part. And then we're gonna check for the second part. Yeah. So for the second part, normally we just need to check return this word. But before we get the abbreviation, let me use abbrev. So the abbreviation gonna be let me just copy it. It's gonna be this one. Yeah. So this is gonna be the abbreviation, the first letter, last letter, and in between. But we need to check. Yeah, so the abbreviation would equal to word if length of the word less than or equal to 2. So otherwise, we're gonna use the abbreviation of word like this kind of formula. Yeah. Now we want to return a boolean value, true or false. So if this abbreviation is not inside the dictionary. Yeah. So if this abbreviation is not inside the dictionary, definitely it is true. So this is the first case. So if there's no word whose abbreviation is equal to the word's abbreviation. Yeah. But we need to check the second case. So for the second case is that we want to return a true. So for example, for this cake. So if we're gonna use this word, the original word. So if word inside the self.s inside the set, yeah, and self.nd dictionary with this word with the abbreviation equal to 1. It means it is unique, so we're gonna return a true. So this is gonna be the second case, and this is gonna be the first case. Yeah. Now let me just run it to check. It is wrong. Yeah. But before that, let me just check what is the self.d. Yeah. Let me check the dictionary. So for the dictionary, it seems okay. I have four words inside, and all those words are the abbreviation. It is okay, I think. Yeah. Now I want to check this abbreviation. If there are two not, let me just delete this not, because if there are two not, it means it's gonna be delete all the not. So not abbreviation inside self.d. Yeah, so if it is inside, it means I'm gonna return a false, but it should not inside, so I'm gonna return true. Now let me just run it. Now as you can see, it works. So this is for checking the second case, the first case from here, and this one is for checking the second case. Yeah. So even there is the word, if there is a word inside the abbreviation, but it should be unique. So I need to use a dictionary with this abbreviation should equal to 1. So if it is equal to 2, definitely it means it is not unique. Yeah. Now let me just submit it to check. Yeah, I think I didn't submit this part. Yeah, I submitted, but I didn't have this part. Now I have something wrong. I think that is because I just use a print. I should not use that. Now let me just submit it. As you can see, it works, and I think the speed is okay. Definitely this is not a good problem, but we have to solve it. Thank you. See you next time.